Okay, let's continue our second hour. Okay, let's continue the model. Okay. Let's still take a look at this table. Okay. There are several questions right here. Okay. First one is data size. Okay. So when we talk about data size, we refers to n. Okay. If then n is large or small. If we like to use a mathematic method to help us to describe the entire data, which means big X and n. Okay. What if the size, the n, is large or is small? So if the n is very small, so as we mentioned, you can make a very precise model by just simply preserve all the information of n by n if n is very small, which is more efficient because you have enough storage to store all the information n by n. However, if the size of n is very large, billions, millions, billions, or even larger, okay, how do we apply mathematical method to all those n by n data? Okay, there are several approach. Okay, we only mention it here, but we only mention very basic things right here, and we will go back to all those different approaches later in the class. Okay, it is very large. Okay, so from the perspective of statistic, 就是统计学的观点来说 ，okay, we can do sampling, right? If the amount of data is too large, okay, you can simply perform sampling on those data. Okay, if your sample is good enough, your sampled data will be very similar. The distribution of your sample data will be very similar to the entire data. So that is one of the approach. Okay. The next one, okay, categorical feature or numerical feature. Okay, if something like that, okay, if that is height, for example, in centimeter, okay, for example, 120, 100, 130, 145, that is called numerical feature, right? But the eye color, for example, it is black, it is brown, it is a blue eye, something like that. As you can see, if it is numerical data, all those data can perform add, abstract, divide, or multiplies. All right. However, you cannot add a black eye to a brown eye. So for categorical data, you cannot perform those calculations, right? So you have to apply different statistic method or mathematical method or some preprocessing to handle categorical data. We will talk about it later, okay? But you have to notice that before you right now, okay? And even more, black eye is not larger than blue eye or green eye because you cannot compare those categorical data, right? You have to notice that, okay? But you can compare two numbers. 130 is larger than 120, okay? Have you noticed that? Let's do things very important. We're talking about Y, okay? If Y is categorical data, means This specific problem is classification problem, which means you would like to do a prediction. You would like to use the value in big X to predict Y, and Y is a category. And this category, it could be something like high, medium, low, or class A, class B, class C, or brown eye, blue eye, black eye, something like that. Those are categorical target. Okay, if your problem is like that, you need to analyze the big X to predict which category this entry, okay, this data will fall into this category. This problem is what we call classification problem. Okay, if your Y, your target, is numerical, like salary, right? Like temperature, like a distance, something like that. If your Y is numerical, then we call this problem using those big X to predict Y, and Y is a numerical target, and we call it is a regression problem. Okay, in Mandarin, 中文就叫做上面叫做分类问题嘛，那下面这个 regression 的问题叫做 regression 的中文叫什么？回归啊，因为它其实没有什么，就是你中文很难，就是你中文你也不知道为什么回归叫 为什么 regression 叫回归了哈，或者是中文的问题了哈。Okay, in Mandarin, it is called classification problem， 就是分类问题啊，分类问题嘛，或者是 regression problem 就是回归问题。它们没有什么本质上的差别，它们唯一的差别就是那个 y 到底是数字还是类比。Okay, so let's take a look at this. Okay, so we have a matrix. Okay, we have a lot of data from 1 to n. Okay, usually those n data we call it training data， 就是训练嘛，训练的资料。And we have n features. Okay, they are aggregated as big X. Okay, we have a Y which is a target. Okay, so the model, if I have a model algorithm, the model algorithm helps us to predict Y from using big X. And however, those training data are used by the model algorithm to create such kind of relationship between big X and Y. So we call training data. But after that, okay, I'm talking about the above part. Okay, the bottom part, which we call testing data. What is the testing data used for? Okay, when we create several different models, okay, by using different modeling algorithms, for example, M1 x to y, right? M2 x to y hat, M3, okay, we have x to y hat. Okay, we have 3 different models created by different modeling algorithms. Okay, how do we know which model is much better than the other ones? How do we know? So in practical, usually we have another set of data which is called testing data, T1, T2 to TT. Okay, so all the data right here, and here. Okay, they are available for you to test your model. How do you test your model? For example, okay, we have M1, right? So X, okay, we put all those testing data to your algorithm and produce Y hat. Because your model can predict, your model, by learning the relationship by your training data, okay, so your model, you input big X, your model can output predict Y. So by using the testing data, okay, you input the big X or your testing data to your model. Your model output Y hat, okay, right here, Y hat. However, meanwhile, you have the ground truth answer. Ground truth 就是正确答案哈。Ground truth answer right here, which is Y. You can simply compare the prediction value Y hat and Y. Okay, to see the difference between Y hat and Y. Okay, of course there are certain methods that help you to do such kind of comparison. Okay, and we'll talk about later. So for M1, M2, and M3, you have Y hat 1, Y hat 2, Y hat 3. Okay, there is evaluation method to help us to make sure which one, M1, M2, and 3, or Y1, Y hat 1, Y hat 2, Y hat 3, which one is much close to the Y. This is right here. The closest one wins, and we consider that model is much better than others. That's what we call testing data. There's a very important rule you have to remember, that when you create this model by using training data, your testing data never participate in the training process. 中文讲，再讲一遍哈。你在做你的模型的时候，用 training data 的时候，你的 testing data 绝对不能参与模型的建立。就刚讲英文一模一样哈。So that is but what exactly a model is? So let's take a look at a very simple modeling algorithm. The first one is what we call linear regression in Mandarin， 它就是线性回归嘛。对吧？线性回归嘛，这一些哈，线性回归嘛，Let's take a look at this, okay? This figure, okay? That is X, that is Y. So basically, if I draw this one, it's much like this. That is X, okay? Since that's very simple data, so we have only one feature. We don't have n feature, we have only one feature. And the Y is right here. So they're about maybe 20, okay? For example, we have 20 data points in this figure. Okay, and the relationship with plot of data using so we think it's the first data, so it should be for example 0.01 0.2 So we have some table this data. Okay, so what in here we have only one x1. Okay, we would like to describe this data visually. How do we describe it? First question is human are smart, so we might think the relationship between x and y that looks like linear. So maybe I think it's a very simple line. The relation between